Network address translation operation. So let's have a look at why we actually need something like network address translation. So as we've heard throughout the course, there are ways to make IPv4 addresses last longer. So one of these was the creation of the RFC 1980 private address space. In other words, the private range of addresses, your 10.anythings, your 172.16 up to 172.31.anything, and your 192.168.anything. So the idea with these address spaces are that you can use them to create addresses on the inside of your network, and you don't have to care about what happens on the outside of your network. So even if you change ISPs, it doesn't make a difference because your internal address structure basically has nothing to do with what you do on the outside. And this also means that multiple organizations can use the same address structure on the inside of their networks. Now the problem with that is these private addresses are not allowed to be routed on the internet for the simple reason everyone can use the same addresses. So in other words, they're not unique. So how do we actually do this? How can we have addresses on the inside of our network that's not allowed to be used on the internet? And yet we've seen that organizations actually provide internet access to their users, even though they use private addressing on the inside. Now the answer to that is network address translation. In other words, the process of translating an internal private address to a public routable global address. So I've mentioned before, just to recap, these are the ranges of private address spaces. So if you are working in an environment, even if you're at work or at home, etc., chances are, if you take a look at your current IP address on your device, chances are it will be an address that is in one of those private address ranges. So you can basically realize that somewhere in your network, some other form of network address translation is taking place. So what exactly is NAT? So NAT is a process that is used to translate network addresses. Its primary use is to conserve public IPv4 addresses. Now basically it's implemented at your border network device. So in other words, either a firewall or your router that connects to the ISP. Now it allows networks to use private addresses internally and only translating to public addresses when needed. So in other words, when traffic flows in and out of your internal network. Now devices within the organization are all assigned private addresses because the addresses are still unique locally. They don't need to take part in any form of address translation. So network address translation doesn't actually affect communication between your devices on the inside of your network. But when traffic must be sent or received to or from other organizations on the internet, that border device, the router or the firewall, translates your private address to a public, globally unique address. And by the way, that address you will most probably receive, not most probably, you will receive from your ISP, from your internet service provider. So here's an example. So here we have a network. You'll see the highlighted area is the private address space. So in other words, this is an organization's internal network. So R1 is on the inside of the network. It really has nothing to do with NAT. But then we have R2. R2 is our border router. It's the one that connects to the internet service provider. So R2 basically signifies the end of your private network and the start of the public network. So in other words, NAT would be enabled on that device to translate between the private addresses on the inside of your network and the public address space that sits on the outside of your network. So NAT terminology. Now, the inside network is the set of devices using private addresses. So basically, inside network is your organization's local network. The outside network refers to basically anywhere else. So inside is us, outside is everyone else. Now, with that terminology, it includes 4 types of addresses. We have an inside local address. That is our private addresses on the inside of our network. Then we have an inside global address. And remember, inside doesn't literally mean inside your network. Inside, quite frankly, just means inside your organization. So it's a network that's associated with a specific organization. So the inside global address is a public IP address that is associated with your network. Now, in most instances, it's basically the IP address of the interface on your router that you use to connect to your ISP. So that's your inside global address. Now, outside local address would mean technically it's a private address that is on the inside of another organization, and an outside global address is a public address associated with another organization. But I'll let you in on a little secret. Basically, from our perspective, if we look at it from our perspective as the inside of a network, an outside local address and an outside global address look the same to us. Think about that for a second. The outside global address is the public address. Okay, so that is something that everyone sees, public IP address. But can you see the private addressing of another organization? In other words, can you see the local addresses of company B if you are in company A? Short answer is no. That's the idea behind private addressing. So basically, from our perspective, if we are on the inside of our network, another organization's local and global addresses are essentially the same thing, at least from our perspective. Okay, so this is just another one that demonstrates the same principle, what I mentioned a minute ago. If you take a look at this little example down here, we have PC1 on the inside of our network, and then we have R2 that sits on the boundary of our network. So the inside local address, as you can see, matches what we have for the PC. So 192.168.10.10. Secondly, our inside global, remember global refers to public IP addresses. As you can see over there, it's the IP address of the outside interface of R2. In other words, the interface that connects to ISP, the last point of our sort of organization. Now what we're trying to do is we're trying to connect to the web server. Now the web server is somewhere else in the world, doesn't matter where. Point being, it's not in our organization, and it's probably somewhere attached to someone's private inside network. Okay, so take a look at that. The outside global address of the web server is 209.165.201.1. But notice the local address. Remember what I said. Even though chances are the web server may be using private addressing on the inside of the network, we don't know. We don't know what's happening on the inside of someone else's network. So from our perspective, the outside local and outside global addresses of another organization's devices look exactly the same to us. We can only see the difference between our inside global and inside local addresses. Now we get 3 kinds of NAT. Our first kind of NAT is static NAT. Okay, static NAT is basically a one-to-one mapping. So in other words, one private address mapped to specifically one global address. So these mappings are normally configured by your network administrator and they remain constant. They don't change. Now, you might ask, why would you need this? Now, it's particularly useful when a server is hosted on the inside network, but it must be accessible on the outside network. So you quite literally always set up a static mapping for that. Now, a network administrator can SSH to a server in the inside network by pointing the SSH client to the inside global address. So this is just an example. If you take a look at what we call the NAT table. Now, NAT table is basically just a list of translations that have been done, or mappings, we refer to them as translations, that have been done by NAT. So in this case, with static NAT, if you take a look at the inside local address column and the inside global address column, you'll see it's basically one-to-one mappings. It's set up statically, so it says the 10.10 inside address always lines up with the 200.226 global address. Okay, just bear in mind, if you have more than one public IP address, more than one global address, you obviously have to organize this with an ISP, and you may have to pay for extra IP addresses. So the inside addresses, private addresses, we can go and assign as many as we want. But for outside addresses, you are actually going to pay for them. Now, the next owner that we get is called dynamic NAT. Now, dynamic NAT is closer to what you think NAT should be. It uses a pool of public addresses. So in other words, you could get 5 addresses, say for instance, from your ISP. And then what happens is your internal devices can use those addresses on a first come, first served basis. So what that means is, if you have 50 devices on the inside of your network, the first 5 devices, if you only have a pool of 5 public IP addresses, only the first 5 devices will be able to have a translation made. Other devices have to wait until one of the pool of public addresses frees up, and then they can try and use it. Okay, so it's not exactly what we think NAT is, and it does have its uses, and especially in older networks, but it's an easy way to limit the amount of incoming and outgoing connections that you want to maintain in a specific network, especially if you are sitting in an organization that has limited access to the internet. So in other words, if you are sitting in an area where there is really limited internet connectivity and you don't want everyone accessing the internet at the same time, this is a possibility. So if we take a look at this table, you'll see that local addresses are still assigned to global addresses on a one-to-one basis, but the mapping happens dynamically. The only problem is, if all 5 addresses have been mapped, no other devices can connect until one of the mappings frees up. That brings us to port address translation, also referred to as PAT. Now, this is most probably what most people think of when they think of NAT, because port address translation is quite literally which most of us are talking about when we're talking about NAT. So the idea is that PAT, or port address translation, allows us to map multiple addresses to multiple private addresses to a single public IP address. Technically probably around 4,000, it depends on who you ask. Now, it makes use of a combination of source port addresses and IP addresses. So in other words, on the concept of sockets, basically. It's not just identifying a conversation via source and destination IP addresses. It also uses port numbers. Now, PAT, why it's still referred to as NAT, the other name for PAT is called NAT overload. So in other words, it's network address translation in which an address is overloaded multiple times by using port numbers. The port numbers also are used internally, if you remember TCP, to sort of send traffic to the correct applications on your devices. Now, the PAT process also validates that incoming packets were requested because it can track the port numbers as part of the conversation. Thus, it adds a degree of security to the session. But please remember that even though people are using things like NAT and PAT, etc., for security purposes as well, because it hides your internal address scheme, that's really not what it was designed to do. In fact, it can break things in your network because of that functionality. Network address translation was designed to conserve IPv4 addresses. The security aspects are really just a knock-on effect. So let's compare. Let's say compare NAT and PAT. NAT translates IPv4 addresses on a one-to-one basis between private IPv4 and public IPv4 addresses. So whether it's static NAT or dynamic NAT, it's always a one-to-one mapping. Now PAT makes use of both an address and a port number, so it's able to overload an address. Now NAT forwards incoming packets to their inside destination by referring to the incoming source IPv4 address provided by the host on the public network. Now with PAT, there's generally only one or very few publicly exposed IPv4 addresses. PAT is able to translate protocols that actually don't use port numbers, so it can even translate ICMP. But each of these protocols are supported differently in PAT. So it's not to say, by the way, even if it's something like TCP or UDP, it's not to say that the port number association used by PAT is the exact same one that you originally had in your conversation. Think about it. There's a chance that if you have 4,000 devices trying to connect using the same IP address, there's always the chance that 2 out of the 4,000 devices may be maintaining a conversation using the same port numbers. Then obviously PAT needs to be able to make a plan to assign other port numbers to the conversation. And with things like ICMP, where we don't use the port numbers, it actually goes and assigns identifiers on its own. So it's not, even though it uses port numbers, it's not explicitly dependent on those port numbers being available. Secondly, or that it has to use the ones that are already in use in the conversation. Now, what's the benefits of NAT? It conserves the legally registered addressing scheme. Secondly, it increases the flexibility of connections to the public network, because if you change an ISP, you don't have to change your addressing. And that as a knock-on effect also provides consistency to your internal network addressing schemes. And then lastly, as I've mentioned, a knock-on effect of all of this, because of the translations, it hides your internal address structure. So it provides a form of network security. Disadvantages are, firstly, obviously, because there's a translation step, there is a slight slowdown. So the performance of your network may be degraded. End-to-end functionality, so in other words, connecting from point A to B, may be degraded because of the slowdown. And secondly, some protocols may not function properly because the whole end-to-end IP traceability is lost. Now, tunneling is a process of converting IP version 4 to IP version 6 or vice versa for traversal through certain sections in your network. Address translation can actually make this process a bit more complicated. And then also, because it sometimes changes the port numbers, an initiating TCP connection maybe, or initiating TCP connections could possibly be disrupted.